classifying some 3D figures. Okay, so 3D means a three-dimensional object, something that you can hold, right? And we're going to classify them based on their characteristics. So when I say classify, what does that mean? Organize them. Yeah, good. I want to group things together based on their characteristics, based on what they look like. Okay, so we're going to start on the side that says 11.1 notes. So go ahead and put your name and today's date on there. It is the 7th, 4/7. Just take a sec, put your name and today's date. If you didn't grab them from the back, go grab them from the back. Okay, and so we are going to talk about different 3D figures and their cross sections. So in this section here is essentially all the different types of shapes we're really going to be talking about. Some of them you might have seen before. Some of them might look a little new to you. We're going to kind of bounce around a little bit within these. So just make sure you are paying attention, because I'm not going to go necessarily in order as we look at them. We're going to kind of switch through as we work through. So we're going to start with this first one, which is a rectangular prism. So I'm going to hold it up for my people online so they can see me. This is a rectangular prism, and I'm going to hold it up for you guys. So everybody look up at me. Here's a rectangular prism. Okay. Whole bunch of different sides. All right, tell me something you notice about this rectangular prism. Okay, so over here, Katie's saying there's a square here, there's a square here. Good. That's one thing that you notice. What else do you notice about this? Nothing wrong. Can't be wrong. What else do you notice about it? There's what? There's 4 rectangles on it. Good. So there's 1, 2, 3, 4 rectangles, 2 squares. Good. What else do you notice about it? What does it remind you of? Kind of like a box, yeah, but like essentially a longer box almost. Where have you seen a shape like this in the real world? A building. Good. Where else have you seen this? A rectangular prism. Where else do you think you've seen this in the real world? Close your eyes and think for a second. What else would be this shape? A filing cabinet. Good. Yeah. One of these. That's a rectangular prism. Good. Anything else? A house can be built like this. Yeah. If you got a really long house, that's another choice. Good. What else? Anything else you can think of? A box, kind of like a longer box. You get like a, some longer packages depending on what you get, right? Yeah. Someone else in my other class said like a semi-truck. Or you think about a semi-truck, that's a rectangular prism as well. So a prism is something that has a base shape and a top shape that are exactly the same, right? So your bottom and your top have to be the same, and they're also parallel. They're never going to touch. So in this particular one, my base shape is a rectangle, right? That's at the bottom and the top, and it's like a little bit longer of a box. That is my base shape. So in my picture here, we're going to color in our bases. My base is at the bottom, right over here. And then your top base should be parallel to it. So at the top, it should be the exact same picture, right? The exact same shape. Absolutely congruent, the same size. So there are 2 bases. And in this picture, my bases are rectangles. So we always name a prism after whatever shape is the base shape. So since this one has a rectangle at the bottom, it's called a rectangular prism, right? It's based on the rectangle at the bottom. Okay, so a prism has 2 faces, a top and a bottom, that are exactly the same. Now, there are some more prisms in this section. What's another picture of a prism in this section? So same top and same bottom base shape. A cylinder. Yeah, cylinder looks like this. Here's a cylinder in the real world. Like this. Here's a cylinder. What is the shape that's the base of my cylinder? A circle. Good. So a cylinder is a type of prism that has a base that is a circle. Now, technically speaking, you could call it a circle prism, but cylinder is just like the very fancy term that we call it, right? It's got a very special name. If you're thinking about the real world, when have you seen a cylinder in the real world? A Pringles can, a soda can. What else? Anything else? Like a water tower, yeah. A pillar, yes. There's a lot of cylinders in the real world. A can, just essentially a can of anything. You know, when you go to Aldi's and get cans, eat them up your beans, whatever. That's a cylinder. Circle at the top, circle at the bottom. All right, there are still more prisms in this picture. What's another prism in this picture? Triangular prism. Good, it has the name prism in it. So this one's called triangular prism. What's the shape of the base? A triangle, yeah. So I've got the triangle down here at the bottom, got a triangle at the top. I've got two triangle bases. And so this is a triangular prism. So I've got a picture here, or I'll show my online people. This is a triangular prism. It's like this. And I'm going to show you guys. Here's a triangular prism. So it's got triangle at the top, triangle at the bottom, and it's connected like a triangle box, essentially. When have you seen this in the real world? A tent. Good. Anything else you can think of? A tent. What else? What else would be this shape?
Someone's roof.
Someone's roof. Yeah. That could be like the roof of the house, right? Triangular prism. Mm-hmm. Like a what?
A tent.
A tent. Yep. What'd you say? It's got three rectangles on the side, right? Because it's a triangle, so it's got three sides, so it's got three rectangles attached to it as well. Maybe like, I don't know, does cheese come like this? Yeah, those kind of blocks on the playgrounds, okay? All those things are triangular prisms. So again, prism is same top, same bottom, right, that are congruent, and they're never going to touch. They're parallel. There's one more prism in this picture. Or in this section. What's the last prism? A cube, yeah, good. Cube is also a prism. So all these ones in orange are prisms. And what's the shape for the cube? That's the base. Square, good. So you've got square bases here. Two square bases. Okay, so cube is very similar to a rectangular prism, right? But because it's a square, all of them are exactly the same, right? So if you look, here's my square, here's my cube, here's my rectangular prism. It's essentially the same thing. One's just longer than the other, right? The rectangular one is longer than the cube one. So cube one, where have you seen this in the real world? A cube. A box. What else? What else is a perfect cube? Ice, yeah. What else? A Rubik's Cube, yeah. A dice, all those sort of things are a perfect cube. All right, so those four are prisms. I don't know if you want to like circle them and say that all four of those are prisms somehow, but I'm kind of color coding mine. All four of these ones are prisms. A prism, and again, I'm just going to write at the top. A prism has two congruent bases. And we name it based on whatever the base is, right? So if the base was a, I don't know, a 20-sided figure, then we would call it a 20-sided prism, right? So whatever the shape is at the bottom is what you call the name of the prism. All right, so those 4 are prisms. Now, there's one that's kind of like all by itself over here, which is a sphere. It's like its own special little section. It's not a prism, but a sphere, I'm sure you have seen before. What does a sphere look like? It's like a ball. Yeah. So a sphere is like its own very fun little own section, right? You think about a ball. You can think about like the Earth is a sphere. You can think about all the planets are spheres, right? Dippin' Dots are spheres, right? Anything that's essentially a 3D circle is a sphere. So it's its own separate little kind of section. It has its own properties. There's nothing else like a sphere. It's its own little thing. The last one, the last section, so we talked about prisms, we talked about spheres. The last section are these 3 right here, these 3. And they all have something in common. What do you notice, excuse me, about those 3, excuse me, that are left that we haven't looked at yet?
They're all triangle-based figures.
They're all what?
Triangle-based figures.
Triangle-based figures, so they all have, yeah, some kind of like triangles to them. What were you saying, Marcia?
All of them with a point.
They all go to a point. Very good. So the 3 that are left over are all types of pyramids. So think about, you know, like the Egyptian pyramids, right? They all come to a point, all 3 of them. But they have a different shape for the base. So a cone has a point that it comes to. What's the shape of the base, though? A circle. Good. So a cone is a type of pyramid. Okay, it comes to a point. So when you think of a cone, what do you think of in the real world? This one's broken, but what do you think of in the real world when you see a cone? Ice cream cone. Yeah, if I flip the other way. What else do you think of? Teepee, birthday hat, right? All of those are cones. Good. There are 2 more. Both are pyramids, but again, it's the shape of the base that's different. So a square pyramid comes to a point. What's the shape of the base?
Square.
A square. Hence why it's called a square pyramid. Crazy, right? Square pyramid. And again, comes to a point. And how many bases does it have?
1.
It only has 1 base. So a prism has 2 bases. A pyramid only has 1 base. Last one's a triangular pyramid. Again, comes to a point. And what's the shape of the base? A triangle. Good. So, oh, dang it, it just froze. Oh. Okay, so at the top, where we put prism has congruent bases, we're also going to write the word pyramid. So just give me a second while I test. There we go. Okay, so prisms are these orange ones. Pyramids are the blue. They have 1 base and they come to 1 point. One base and they come to 1 point. All right, now I've got 1 shape left that's not listed there that I'm going to show you. And I want you to tell me what kind of shape it is. Okay, so I'm going to stop sharing so my people can see. So my online people, I'm going to show you first. Okay, and now my live people, I'm going to show you guys. So take a look. Okay, here's the shape. Here's what it looks like on this side. Here's what it looks like on this side. All right, now, knowing that, first of all, is this a prism or is this a pyramid? Prism. Why? It's got two bases. Now the question is, what's the base? Rod thinks a hexagon. Do we agree with Rod? Yeah, it's a hexagon. Hexagon at the top, hexagon at the bottom, six-sided figure. So what do I name this shape? Hexagonal prism. Yep, so there's your answer. A hexagonal prism. Hexagonal, actually. But you can say hexagon prism, or you can say hexagonal prism. Essentially, it's just you're taking the word, you're making it from a noun to an adjective, but if you just put a hexagon prism, that's fine. Okay, you'll understand. All right, so those are all of our 3D shapes. Was this hard as it gets? Okay. Those are all the 3D shapes that we're going to be talking about. And so we've classified them based on if they have one base or two bases, or if they're their own very special sphere. Now, we're going to, this time, take some 2D figures and we're going to rotate them. What does rotate mean? Turn. Okay, so I'm going to take some 2D figures. What's a 2D figure? A flat one. And I'm going to turn them. And I'm going to go a little out of order here. So I'm going to start with, where's my circle? Maybe I'm not. Oh, here it is. Okay. Here's my circle. So I'm going to stop sharing here. Okay, here's my circle. Everyone see it? Everybody look at me. Everybody look at me. Everybody look at me. Here's my circle. Okay, if I take this circle and I do this to it, I rotate it. Rotate, 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 rotate very, 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 very quickly. What shape am I making? What 3D shape? A sphere. Very good. So if I take this circle and I rotate it quickly, I make a sphere. Good. Write that down. Okay, so we're kind of working backwards here. Now, if I take a triangle, here it is. It's the second one. I'm going to take this triangle and I'm going to rotate it. Rotate it like this. So everybody look at me for a sec. Rotating my triangle. Really fast. Okay. What shape is it making at the bottom there? It's making a circle at the bottom. Then, when I come to the top over here, is that point moving? No, it's just staying right where it is. So what shape has a circle at the bottom but comes up to a point at the top? A cone. Very good. So this shape, if I rotate it fast enough, makes this shape right here, a cone. All right? So this shape makes a cone. Last one, and this one's going to be hard, so kind of like bear with me. I'm going to take a rectangle now. If I can find it, here's my rectangle. Beautifully done, I know, right? Amazing. Here's my rectangle. I'm going to take this rectangle, and I'm going to rotate it, right? And turning it, turning it, turning it. Okay, so everybody just look for a second. Rotating, rotating, okay, kind of. Rotating. All right, so what shape is it making if I go this way at the top? It's making a circle at the top. What shape is it making on the bottom? Also a circle. So what shape has a circle at the bottom and a circle at the top? A cylinder. Good. So if I rotate this fast enough, this is the shape I'm going to get. Good. Cylinder. All right, write that down. Okay, sorry guys, I have to go back and forth because I got some online groups. Okay, cylinder. So by rotating a 3D shape, or excuse me, a 2D shape fast enough, I can make a 3D shape. All right, are there questions on those three? Do we feel okay? Yeah? All right, now, last part we're gonna do here is stacking 2D figures. So when I say stacking, what do I mean? Putting them on top of each other. Okay, so I want you to think about breakfast time. I want you to think about some pancakes. We're going to stack pancakes. That's what I want you to visualize in your brain, okay? We're going to take 2D pancakes, right? So if you think about a pancake, it's flat. We're going to take that pancake and stack it on top of each other. In this first section, we're going to name the solid form by stacking congruent shapes. What does congruent mean? The same. Okay, so congruent is same size and same shape. Okay, same size, same shape. So I'm taking a pancake, just a regular old pancake that is a circle. Okay, I've got my circle pancake. Here it is. Beautiful, right? Take that pancake and I just place more on top of each other, exact same size, and I just build my way up. So it's a circle at the bottom. What shape is it at the top? It's a circle again. So what shape is a circle at the bottom and the exact same circle at the top? A cylinder. Beautiful. So I've got my circle at the bottom. I like to draw a picture for myself. Circle at the top. Right, I've stacked them on top of each other. That's a cylinder. And a cylinder, remember, is a type of what? It's a type of prism. Good. All right, now imagine I've got a square pancake, because I'm an amazing chef. Square pancake. Got my square at the bottom, and I stack, and all the squares are exactly the same up to the top. Square at the bottom, square at the top. What kind of shape am I making? A cube. Beautiful. Square at the bottom, square at the top. That's a cube. It also could be a rectangular prism depending on how many I stack, right? For our purposes, because it's a square, we're just going to stick with the cube though. But yes, you are not wrong. If I do enough squares, I can make it taller, right? Which would be a rectangular prism. So I could do that, but for our sakes, we're just going to do cube. Again, cube is a type of what? Prism again. Hopefully you're noticing a pattern. Okay, last one, a triangle. If I stack congruent triangles, they stay the same, they work their way up. Triangle at the bottom, triangle at the top, what am I making? Triangular prism. Good. If I stack enough, it's going to look like this one, the tent. Right? Triangle at the bottom, triangle at the top. They've stacked onto each other. A triangular prism. Again, it's a prism. So when you stack congruent shapes, you will always make a prism. Always, always, always. So congruent shapes will always make a prism. Always, always, always. So if you see the word congruent, you should be thinking about prisms. The question just becomes, what kind of prism? All right, questions so far? Feeling pretty good. All right, now in the next section, excuse me, we are going to continue stacking pancakes. So keep that same idea in your brain. But this time, instead of stacking congruent pancakes, we're going to stack similar pancakes. What does similar mean? The same, but a tiny bit different. What part of it is different? The size of it is different. So when we talk about similar, right, similar means same shape, but a different size. So I want you to think about if I'm stacking pancakes this time, the pancakes are going to get smaller with each step that I take, right? So I'm going to start with a normal size circle pancake, my normal circle pancake here. But then each one that I put on top of this pancake is going to get smaller and smaller and smaller and smaller and smaller and smaller and smaller till what? Comes to what? It comes to 1 point up at the top. So I've got a circle and I'm stacking them until they get pink up to a point at the top. So what shape gives me a circle at the bottom where they continue to go up, 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 up until they reach a point? A cone. Very good. And a cone is a type of what?
Prism.
Oh, it's not a type of prism.
Pyramid.
It's a type of pyramid. Good. Okay, hopefully you kind of picked up on the pattern here. Now I've got a square pancake, square, and again, I work my way up until dink comes to a small point. What kind of shape is that?
Square.
Square pyramid. Good. All right, last one. If it's a triangle, and again, I stack them and they become smaller, 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 right? So they come up, boop, 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 to a point. What shape is that? Triangular pyramid. Good. Okay, so now last part. Well, not last part, it's like similar shapes always create what? Always create pyramids. Good. So if you see similar, it is always creates pyramids. Okay, that's kind of easy to visualize, but there it is for you. So it's kind of noticing some patterns here. Okay, now for our last section, we're going to talk about something called a cross section. So we're actually going to watch a quick video. It is very quick. It's like 1.5 minutes. Okay, the video, can someone let whoever that is in? The video is going to talk about something called a cross section. And a cross section is where I take a 3D shape and I cut it and I make a slice into it. So you can think about a 3D shape like a cake, and then I cut the cake and I take a tiny sliver of it out. I make a 2D flat shape. So depending on how you cut the cake, you could get a different shape. So we're going to watch a video. It's going to talk about cross sections, and then we're going to fill out that small chart right afterwards. Okay? Yes, Alex.
Is that one of those nice Costco maps?
Yes. Oh, did I close this off? Oops. Give me 1 second. Let me pull this up. Okay. All right, so make sure you're watching the video because it explains it way better than I can explain it with the pictures, so make sure you're watching the pictures.
That's yours. Slicing solid, three-dimensional figures results in different two-dimensional shapes depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing solid, three-dimensional figures is important for geometry and ninjas.
Okay. So we've got, right, 3D figures that we can cut like a cake, and they make different shapes depending on which way you cut them. So we're going to cut them both parallel and perpendicular to the base. So the bases are horizontal. If I cut it parallel, which way do I have to cut it? Also horizontal, right? I'm cutting the same way. If I'm cutting it perpendicular to the base, which way do I have to cut it? Up and down, right? Straight through it. Good. So we're going to cut different shapes based on, right, which way we want to go. So if I'm cutting a cylinder horizontally, which is parallel, what shape am I making? Making a circle. If I cut that same cylinder vertically, oops, where's vertical? Vertically, what shape am I making? A rectangle. Good. So come down here. This is a cylinder, like you said, and the cylinder is a type of what? It's a type of prism. So when I cut it parallel to the base, parallel means it's horizontal. It ends up making a circle, which just so happens to be the same shape at the bottom. And when I cut it perpendicular or vertical, right, I end up making a rectangle, which is what you guys told me. Okay, so we're going to use this same idea, and we're going to fill out the rest of the chart. Now, next one that's right underneath it, is that a pyramid or a prism? It's a prism. And what type of prism is it? Hexagonal prism. Good. Okay. If I cut this picture horizontally, right, at the bottom, what shape am I going to get? Oh, what's at the bottom? Yeah, a hexagon. Yeah, so because the shape at the bottom was a hexagon, if I cut it horizontally, I'm still going to get a hexagon. Hey, that's the same shape for both of these as the base. It's the base shape. Base shape, right? It's the same base as the picture, literally. Okay, but if I cut it vertical, perpendicular, what kind of shape am I going to get? A rectangle. Yeah, I'm still going to get a rectangle. So for those two prisms, what do you notice? They both get rectangles when I go vertical, and that's every single prism ever. If you take any prism and you cut it perpendicular, you're going to get a rectangle. If you cut it horizontal or parallel, you're going to get the shape of the base. That's not going to change. All right, so those first two were prisms. What shapes are these next two? Types of what? They're both types of pyramids. Good. So for the first one, what shape is that first one? Circle to a point, so it's a cone. Good. Think about a party hat or an ice cream cone. So if I slice it horizontal at the bottom, what shape am I going to get? A circle. Well, hey, look at that. That happens to also be the shape of the what? It's still the shape of the base. If I cut it vertical, what shape am I going to get? A triangle. Very nice. Good. Now, the next one didn't print out very nicely. Sorry about that. It's supposed to be a square pyramid for the second one. A square pyramid. So sorry about that. It just didn't show up very well. Okay, so if I cut it parallel or horizontally, what shape am I going to get at the bottom? A square, which is the same shape as the base. Okay, so hopefully you're noticing a pattern. What shape do I get if I go vertical? You get a triangle again. So what did you notice? What'd you know? Someone tell me what they see in that chart there.
Anytime you go parallel, you'll get the base.
Anytime you go parallel, you'll always get the base, no matter what shape it is. What happens when you go perpendicular? For a prism, what happens? It's a rectangle. For a pyramid, what happens? It's a triangle, and that's every time. Now we got to do our one lone friend, which is the sphere. Homeboy's out here all by himself. But I have a feeling you can guess this one pretty easily. If I cut a sphere horizontally, what shape is that?
Circle.
A circle. If I cut a sphere vertically, what shape is that? It's a circle. Yeah, both of these are a circle. So those are like our funky friends there. He's all by himself. Doesn't really fall into any category. All right, now for the last 5 minutes here, you're about to be an artiste. Are you ready? You don't need to flip it over yet. Nope, stand on the front. We're not doing the back. Stand on the front. You're about to be an artiste. I'm going to show you how to draw pyramids, and I'm going to show you how to draw prisms, okay? Because as we continue on with these, you're going to definitely need to draw them, so I want you to know how to draw them, all right? Okay, so at the bottom here, we got a little bit of space. We're going to start by drawing a hexagonal pyramid. Write that down. Hexagonal pyramid, or you can put hexagon pyramid. Hexagonal pyramid. All right. So, get ready to draw. You're drawing a pyramid, which means what? Comes to a point. What should be the shape of my base? A hexagon. How many sides are in a hexagon? 6. So all I want you to draw right now is just a hexagon, just a 6-sided figure. Okay. Should look like a stop sign, essentially. So you can draw a line at the top and then the bottom, and then 2 kind of like diamond-y points to the sides. That's step 1. So far, so good? Okay. Now, step 2. You're going to draw a point somewhere above the hexagon. Doesn't really matter where, but just do not put it directly above it. Put it off to the side a little bit. It makes your drawing a little bit easier. So go a little to the left, a little to the right. If you go directly up, your picture's going to get very kind of crazy. So I'm going to put mine just up to the left a little bit. And go to the right, doesn't matter. Now, you've got points where all of your lines connected, right? So there's 6 points, 4, 5, 6, where your hexagon connected. All I want you to do is take those points and connect them now, each one to the line above it, or to the point above it, excuse me, with straight lines. So to the best of your ability, you're just going to draw some straight lines. Ta-da! And you have now just drawn a hexagonal pyramid. Does yours look something like mine? Good. Not hard, right? So all you have to do is draw the base picture first, draw a point, and then just connect. And it'll make your life way easier. And the real trick is never put the point right above, because then it makes your picture really, really hard to draw. Okay? Always put it a little off center, just a smidge. Okay. We're going to draw one prism really quickly. We're going to draw a triangular prism. So the one that looks like a tent, we're going to draw. All right, so here's what you're going to do. Triangular prism, remember, it's got a triangle at the bottom and the top. So I'm going to draw 2 triangles that are exactly the same. Same shape, same size. You can draw any kind of triangle you want. I'm going to draw a right triangle. Whatever triangle you draw your next one a little bit above and, again, diagonal. Don't do it straight above. Go a little bit diagonal because it's going to make your life way easier. They're kind of the same. Okay, the trick is always go a little bit diagonal. Then just connect the points that match up. So the top points match, bottom points match, the right points match. And you've just made a triangular prism. Instead of ours looking like it's up and down, it just looks like it might be a little slanted. That's fine. So the trick when you're drawing is to always do everything a little bit diagonal, because then it makes your lines just a little bit easier to draw and connect. All right, my dears, that's all I have for you. We're going to do the backside tomorrow. You don't need to do it. Your homework for tonight is only to finish your homework from yesterday if you didn't finish it yet. So that homework from yesterday was the 11.0 homework about area of 2D figures. If you didn't finish that, you need to complete it and submit it tonight. But otherwise, if you already did it, you don't have any more homework, okay? So please make sure to do it so that we can start the quarter off with a good grade, right? And then we're going to do the back side of this paper tomorrow. Okay, so we're done for today. What'd you think? Not a bad day, right? Pretty easy. It was a day of like visual math, not real like mathy math. So I'm always in for days like that, right? Okay, that's all I got for you. We've got just a minute till the bell rings, so you guys did a good job today.